0.01. This is a strong acid, right?
Of course.
And I said this yesterday. If I have a strong acid, it's going to give off 100%. So 0.01 molar HCl gives off 0.01 molar hydrogen and 0.01 molar chloride, correct?
Of course.
Okay? And then Will said, just take negative log number. That's really easy, right? Okay. Let that be easy. What I mean by that is, we're going to start doing some stuff that's a little bit different, a little bit more involved, a little bit more calculations for something else. But I'm going to put a very simple problem like that on your test, and you're going to want to do all these different things to it. No, that's all you do. Okay? That's it. Okay, well what if I have 0.01 molar acetic acid? Can you find the pH for that?
No.
Why no? Because it's not a strong acid. It does not ionize 100%. It only ionizes a little bit. Okay? As a matter of fact, when I have this, when I have acetic acid, which is a weak acid, I'm not going to have the arrow just go that way. It's going to be at equilibrium. So it's going to give off H positive and what?
Acetate.
Acetate. Okay? This right here is aqueous. This right here is aqueous. This right here is aqueous. Since this is at equilibrium, can't I write a K expression for this?
Yes.
What would it be?
K, H positive.
H positive,
Choke 232.
acetate,
Yes, negative.
Over acetic acid.
over acetic acid. Does everybody agree with that? Is everybody okay with that? Okay? I'm going to throw in a little bit of an A right here. That's called the acid dissociation constant. So now we have Kc, we've got Kp, there's a Kw, now we have Ka.
And KEQ.
Keq is kind of the whole thing, yeah. Okay? Alright, and by the way, it's always like this. Everybody watch. Ka is always the concentration of H times whatever the conjugate base is over the acid. Okay? Once again, Ka is always H positive times the conjugate base over the acid. Does that X make sense there? Anything, right? Whatever this is right here. Okay? Alright, so if we're doing Ka stuff and we're doing equilibrium stuff, then aren't we probably going to do an ice chart?
Hopefully not.
No, we are. And by the way, that also means that this does have a Ka value, and it's 1.8.
Pardon this interruption. At this time, all senior
Times 10 to the
students should be
negative
back
fifth.
in class. At this time, all senior students should be back in class. Thank you.
Are you supposed to just know that that's the Ka? No, I will give that to you. Okay. Okay. So I'm going to do an ice chart for this guy right here. And it's going to look like this. This guy is 0.01 molar. This is going to be
0.
0. Thank you. This is going to be 0. This side's going to gain. This side's going to lose. This is going to gain X. This is going to lose X. This is going to be X. This is going to be 0.01 minus X. Okay? Alright, well I've got my Ka value. It's 1.8 times 10 to the negative fifth, and it equals my products, right, over the reactants. But G. Bill is dying to tell me something about this. What are you dying to tell me?
Will's dying to tell you something about it.
Will is dying to tell me something about this. What do we got?
Something about the negative fifth, probably.
Yes, that's why I pointed at it. This number is smaller than 1 times 10 to the negative 4. So what can we do?
Cancel the x.
We can do this right here. Okay. All right, solve for x.
.042?
4.24 times 10 to the negative 4.
Yeah.
4.2 times 10 to the negative 4. Okay. All right. And then once again, you got to ask yourself, what is x? It's the concentration of hydrogen. So now what do you press? Negative log number. Please do that.
3.34.
3.34?
3.4.
3.37.
3.37.
3.38. No.
Is it 3.37 or 3.38?
3.37.
Alright, there we go. Okay? So, when you're doing strong acids, all you do is press negative log number. However, when you're doing a weak acid, you have to do an ice chart, you have to do an equilibrium expression like this. Okay? Alright. You remember this over here? I said that this ionizes 100%. So if I have 0.5 molar HCl, it gives off 0.5 molar H.
Yes.
Does this give off 100%?
No.
No. So how do I figure out what percentage it gave off?
3.37.
If this is 0.01 molar, and if it was a strong acid, what would it give off?
A week.
0.01 molar, right? It didn't. What did it give off? 4.2 times 10 to the negative 4. So if I take that and I divide it by my original concentration times 100, that will give me my percentage. Somebody do that, please.
4.2.
4.2%. Right? Let me go over that one more time. This was 0.01 molar to begin with. If it was a strong acid, it would give off everything, 0.01 molar. It did not. It gave off that. So take that and divide it by my original times 100. Okay? Alright. You guys try one. That one right there. Calculate the pH of 0.2 molar hydrocyanic acid. Now before you do this, look at its Ka value. 4.9 times 10 to the negative 10th. That's small. Look at this K value. 1.8 times 10 to the negative 5th. That's small. Okay? What does that mean? It means it really, really favors the reactive side, the left-hand side. Which means it does not give off a lot of hydrogen. That's why it's a what? Weak acid. Does that make sense? If I'm stuck over here, it's not giving off a lot of hydrogen, so it's a weak acid. So here's my question. That guy, or that guy, which one is the weaker acid?
This one.
Why this one?
Because it's a smaller number. So
Because it has a smaller number, therefore I'm even further to the left. Does that make sense? So what I'm saying is this. The smaller the Ka value, the what? The weaker the acid. The larger the Ka value, the stronger the acid. Okay. See if you can do that one. Okay. This is 0.20 molar. This is 0, this is 0. This side has to gain, this side has to lose. This is going to lose x, gain x, gain x. This is x, 0.20 minus x. So Ka, which is 4.9 times 10 to the negative 10th, equals this times this over this. And this is so small that I can do what? rid of that right there. Okay? Does that make sense so far? Alright, everybody watch. The majority of the time, you're going to be able to do this right here. So I don't even do an ice chart anymore. I just go, it always does this. Whatever your Ka is, it's always going to be x squared over whatever the concentration is. So when I see this problem at the very top, I don't do ice charts anymore. I just say to myself, okay, Ka equals x squared over concentration. Okay? Anybody solve for x?
2
point.
What'd you get?
9.9 times 10 to the negative 6.
Times 10 to the negative
That's
6.
the.
Okay? Is that not right?
I got 2.2 times 10 to the negative 10.
I got 9.
I'm pretty sure
I
it's
got
not.
9.9.
This times this square root. Alright, and once again, when you solve for x, what is x?
Concentration of
H. Let me say that again. When you use Ka and you solve for x, x is the concentration of hydrogen. Okay? So, are they asking for pH? What are they asking?
Yeah, pH.
So then I'm simply going to take that and press negative log number.
5.0.
5.00. Right? Anybody get that? Good. Alright, let's try another one.
In front of the screen.
A 0.1 molar formic acid solution has a pH of 2.38. What is the Ka value? Okay, didn't I say it's always Ka equals x squared over concentration?
Yeah.
Okay? And what did I just say x is?
Concentration.
I just said x is
Concentration of hydrogen.
H. That's right. Okay. Well, I have concentration. It's 0.10 molar. Do I know x?
Yeah.
Yeah, you can find
You
it.
can get
Isn't x H?
Yes.
If I have pH, can't I get H?
Is it
Second log negative number?
Oh, yes.
What do you get when you do that?
4.2.
4 point what?
4.2 times 10 to the negative 7.
Is it 4.2 or 4.0?
I got
4.2 times 10 to the what? Negative third?
Negative
Third.
third, yeah. Third. That's
Okay.
wrong.
But what am I supposed to do to x?
Square it.
Square it, and then divide by 0.1.
I was almost there.
Alright. Somebody solve. Tell me what you get.
1.7 times 10 to the negative 4.
Okay.
Yeah.
Alright. Let's try one more. Calculate the percent ionization of propanoic acid with a 0.250 molarity. The Ka for propanoic acid is 1.3 times 10 to the negative 5th. Okay, isn't it always Ka equals x squared over concentration? Did anybody solve for x?
1.8 times 10 to the negative 3rd.
Is that correct? 1.8 times 10 to the negative 3rd. Okay? Remember, that's H. So I can press negative log right now and get my pH, but they didn't ask for that. They asked for the percent ionization. Remember, if this was a strong acid, it would give off 0.250 molar H. It did not. It gave off this. So take this and divide it by that times 100, and that will give you your percent ionization. What do you get? It's like the small one. 0.72%. Okay? You guys handle that?
So those bonds are like really strong between the hydrogen.
Correct.
And
Because the stronger the bond,
the weaker the acid.
weaker the acid.
It looks good on